Good morning, my students. A new session of physics, chapter motion and acceleration, and the topic is Newton's third law of motion. In the previous classes, I have taught you the first and second law of motion of Newton. Here I am going to describe the third law of motion. The third law of motion describes that each and every action have an equal and opposite reaction. Each and every action have an equal and opposite reaction, and both action and reaction acts on two different objects. This is the third law of motion. What does it mean? That if you push anything, if you are pushing anything, then in against of your push, another reaction acts. What is the proof of that? Just say, I want to move this desk. Or I want to slide this book on here. I want to slide it. I am applying a force here by my fingers. I am applying a force, but the book is not moving. Why? The reason is for my action, a reaction is also acting in against of the action. So it is not moving. That reaction is what? It is another matter. But a reaction is acting in against of this action. And both are equal because the object is in balanced state, in equilibrium. It is in rest and it remains in rest. The force is acting, both forces are acting, but it is not accelerated. So we say that the both action and reaction are equal and acting opposite to each other. If action is acting on this book in this direction, then the reaction will act in this direction. It means on each and every object, a pair of forces always act. A single force does not act on any object. In any case, a pair of forces act. My students, you think now some more about this action and reaction, which are the misconceptions or about this action and reaction. That is, you think that when a force acts, first the action act, and after that the reaction act. But it is not fact. The action and reaction both act simultaneously, not one after one. Both act simultaneously. And so, on this book, when you have started applying the force on this, I have started. Just when my finger is touched here and started to push, in that moment, that instant of time, the reaction also started acting on it. If it is not, then the book is accelerated. And then stop. Yes, if the reaction does not work, then the book is accelerated, applying the action. But the book is not going to accelerate it after applying this action. Why? The action when it starts to work, the repulsion reaction force also start to work same time at the same instant of time. And when the action is increased, the reaction is also increased. And at a certain time they act equal. And when again the action is increased, then the reaction is unable to object or react with the action, and the object is become accelerated. But action when it start, then at that instant of time, the reaction also start to work on the object. First, this is the misconcept. Another misconcept. The action and reaction reject each other, but it is wrong concept. The action and reaction does not reject each other. They do their work according to their magnitude. For example, that action and reaction both work. They do not reject each other. Definitely, they work. How? Just I am giving an instance to you. This duster. I am going to strike this duster on this board. What happens? You see. If it is visible, be careful and see. I am going to strike this duster to this board. You have seen the duster strike the board, and at the same moment it comes back in the same direction or to achieve the same position from where it is stopped. Why? If action and reaction reject each other, then it will stay here. But it is not going to stay here. It comes back in the hand of the thrower. What is the reason? Due to reaction, it is accelerated. Action and reaction both are equal. And due to reaction, the reaction acts on this duster. And the action acts on this board. Due to the reaction, the duster is accelerated. So it comes back to the thrower hand. Then why due to action this board is not accelerated? Question arises. Yes, my student, this question comes in your mind that if action and reaction does not reject each other, does not cancel each other, and due to reaction, the duster is accelerated and come back to the thrower hand, then why the blackboard, this whiteboard does not move? Just I have described that the action and reaction force and magnitude is same. They are equal. And you know from the second law of motion, you know very well. If F is equal to force is equal to F is equal to M into A. Therefore, A is equal to F by N. You know, and from here you know that A is inversely proportional to the mass of the object if the force is constant. If A is constant, I have described you in the second law. If A is constant, then for two objects, to achieve the acceleration, it is inversely proportional to the mass. It means if mass is greater, then the acceleration is less. And if the mass is smaller, then acceleration is more. Now think about the duster and the wall. Because the whiteboard is hanging on the wall. It means blackboard and the wall is joined together and they act simultaneously. But both are combined, just think it is wall. Compare the weight of this duster, the mass of this duster, not weight, mass of this duster and mass of this whole wall, all are connected. In comparison of this duster, the mass of this wall is, I think, 1 lakh times more. Its weight is only not 50 but 40 grams, I think. And its wall weight is how much you can imagine. And it is at least 1,000 times it is more according with the respect of this duster. The force is same. The force is same. Mass of duster, I am writing M duster D and mass of wall M W. Then M W is equal to 1 lakh times of mass of duster. This is the relation. Then if you put here the mass of the wall, then acceleration will be what? 1 lakh times less with respect to the duster. And that is near about 0. Tends to 0, exact 0. Due to this reason, the duster comes back to the floor hand or the ball, cricket ball or anything comes back towards the floor, and but the wall is static because on both objects the acting force is equal, because you know that the action and reaction force are equal and opposite and acts on two different objects. Then both force is equal and they do not reject each other. They act on both objects with same magnitude. But here the magnitude of mass of the object wall is 1 lakh times more than this duster. So the wall is not accelerated and this duster is accelerated. This also, same phenomena also occurs between the duster and the earth. This will be described, I will describe in the lesson next, gravitation. Here, if I want to describe, you confuse because you do not know anything about the gravitational force. It is clear that the action and reaction force does not exact each other, and they work with same magnitude of force on different objects in different directions. Here a unique point is this: the action and reaction force are equal. In balanced force, you have learned that the balanced force are those who does not produce acceleration in a body. And balanced force are also equal in magnitude. You have learned that in previous classes. Here, the action and reaction both are equal force. Their magnitude is same. Then Acceleration cannot be produced in the object, but here the acceleration is produced. Yani a pair of action reaction force is able to produce acceleration. The duster comes back after striking the ball. The duster is accelerated. Acceleration is produced. Here, a unique thing. And one thing more about the action and reaction, which is very important. This, this book is written on this wood board. Yes, by the students. Now think, which forces are acting on this book and in this wooden piece? Two forces are acting. The weight of this book acting in downwards direction. That is gravitational force. The weight of any object is the gravitational force. Means by which force the earth attracts any object towards its center is called gravitational force. And that is the weight of the object, and that is mg. Okay? And on this book, gravitational force is active in downwards direction. Then why not it is falling in downward direction? It means some other force is opposing it. And that force is reaction force of this board on my hand. Suppose it is a table, then the reaction action is this is gravitational force is action. Then the reaction of this disk is opposing the action, and so this book is retaining here. Okay? Then can you say that these two forces, one force gravitational force in downwards direction and another force of this wooden piece in upward direction are a pair of action reaction force? These two forces are called as an action reaction force or not? Commonly, the students say that yes, sir, this is an action reaction force, but the answer is it is not an action reaction force. Why, you ask? The answer is you have learned that the action reaction force act on two different objects, not a single object. And here, the weight of this object, gravitational force of the book acting on the book in downwards direction, and the wooden piece opposing the gravitational force in upward direction, and that also act on this book. Both are acting on the book. The gravitational force is acting on the book, and the force of this disk is also acting on the book. Both forces are acting on the book. Both. So this pair of force is not an action reaction force, because both forces are acting on the book. My students never say that the book is staying on the table due to the action reaction force. And the implement of the third law is also in the zone of your general life. In walking, you use the third law, you extract the earth by your foot, and then by same force, the earth reacts on your foot, and due to help of that force and muscular force, your step is uplifted and you are able to walk. In swimming, you also use the third law. In swimming, At first, you extract the water, you pull the water in backward, and in reaction, the water pushes you and forward. And so you are able to swim in the water easily. If water does not react, then you are unable to move in the water. If it opposes you, then it is not possible to move, to swim in the water. And the third case, recoiling of the rifle. When you fire a bullet from a rifle, the military man feel a strong force on his soldier. A jerk he get to save that jerk. If you fire a rifle in like this, then the rifle may fall down from your hands and you are unable to target your target. So the butt of the rifle is fixed on the shoulder to obstruct the recoiling of the rifle, to oppose the reaction force. This is the reason that you have seen in every case that the soldier is taking the butt on here on his soldier for opposing the recoil. And the last man in the boat. When a boat comes on the bank of the river and he wants to go on the earth, then he pushes the boat in downwards direction. You just apply a force in downwards direction. And then the boat and water both react in upward direction, and with the help of that force, you jump on the earth, on the bank. These are the examples of the third law of motion, and I think that I have tried my best to taught you the third law of motion, and I request that please learn the book also, and then it is easy to understand the third law of motion. After that, we need another look at what time of no, close. Yes, my children, here I am stopping, and next class I will taught you the conservation of momentum. You have learned very well the momentum, linear momentum P is equal to M into V. And in that, we learned that momentum is a conserved for an isolated system. So please, if you have got your book, science book, then please learn it and then you attend my class, and thereafter it is easy to understand the conservation of momentum, and that is the last of this chapter. And in one or two lessons, I will describe some numerical problems related to this chapter, and then the chapter is finished. And my students, this is the last time of Corona, and beware, because Corona is existing on the earth. It does not gone away in this lockdown period. The Corona is present, and if you are not careful, then it comes to you also like other person. So please be careful. If you are coming out from houses, please take a mask on your face or a handkerchief or another thing to protect the inhalation of air which goes through a cotton cloth which protects you from corona. And after a long interval, I request that this lockdown period had given you the blesses your grandfather and grandmother, and that blesses will help you in your life to do progress. Yes, my children. Well, God bless you. Make a nice day.